All right, well, we're back from our overnight break. It's time to get back on our beauty ring project here. We're getting the CNC mill set up now for operation 2, and we're gonna start making some chips. So let me give you a quick little rundown of what we're gonna be doing here, okay? All right, on our beauty rings, this is how we're gonna be clamping these guys down to our round fixture there. I have this clamp ring that I call it, that's got our hole pattern, so we'll use some hex head bolts to pull that down in the center, and then all of our machining is gonna be out here on this face. All we're doing is roughing this in so that we can take it over to the lathe and hopefully just make 1 or 2 finished passes across that face there to clean it up. Doing this is eliminating all of that manual handwork that I'm gonna have to do to cut that off with the lathe. So I'm just trying to minimizing my time in the lathe by using the CNC mill for this, okay? So we are gonna have a, so we're gonna rough it out. It's gonna be sort of like a stair step looking face across there. And once we get that done, we're gonna grab our tung alloy face mill, and there's gonna be a little land right here about 1/4 inch wide, and I'll show you on the sample here. We're talking about that face right there. So we wanna make sure that that cleans up nice too. And it's only gonna be about 20 thousandths that it's gonna take off of that. And if we need to, when we go to the lathe, we can just, skim cut that to make it like a lathe finish across that face there to clean it up. And then we will come in there and hit this chamfer again. I think it's going to eliminate most of this chamfer that I already have in there, but we'll go ahead and hit it with our chamfer tool just to make sure that that is correct. And then that'll be it. We'll pull it out, drop another one in, and keep on going. Keep in mind that the bottom of these are faced. I got this one flipped over so you can see. So all of them are faced on one side. This is the face that we're going to be referencing to on what our heights are, where all this finishes out. So we'll go ahead and get our work location set up on the flex and start making some chips. All right, let's start getting this guy set up. I've already cleaned it once, but I just want to make sure no dust has settled on that face there. Kind of like working on the granite plate. You just want to make sure all the chips and dust is gone. And I've done the same with the back of our ring here. I'm wiping it with my hand, and I think we are good to go. So let's go ahead and get it on there. There it is. Drop right on. And then we can line up our bolt holes right there. Let me get the clamp ring. So I did face this off in the lathe, and even it proved to be a little bit of a challenge, but we got a nice face. But I went ahead and hit it with our little Scotch-Brite wheel on the little angle grinder just to kind of slick it and smooth it, because my goal is to not like mar this finish in any way, with our clamping ring. I want it to look like it was just machined. I don't want to put any gouges or scratches in it. So I wiped it off too, so it should be good and clean. All right, let me get my bolts. And I'm just going to use some 7/16 bolts here with SAE washers. And I got a little impact here to kind of speed up this process. That should be good to go. Okay guys, I'm going to give you a rundown of what we're going to be doing in our CNC mill. We're just going to be roughing this angular surface on there, and just due to my lack of experience and knowledge with the CNC work, I didn't realize how long it was going to take to be able to finish this angular surface with our 3D finishing using a ball mill. And everywhere we looked at it, trying to get a really good smooth finish on there, it was showing where it was going to take upwards to 2 hours to get that milled. So obviously that's going to take too long. I know that it's faster to go to the lathe and set up the compound at an angle and machine that face on there. So that's my plan now. But we are going to go ahead and rough all the material away. All of this material just needs to be roughed off there, just because of the compound being driven by my hands. I'm going to try to rig up something to be able to power feed it. And I'm going to work on that as soon as we get these roughed in to see if we can make that a little bit easier. But let's go through the simulation on what we're going to be doing to rough this in. I will just start with, hold on just a second, I messed up here. I was going to show you. So we turned the beauty ring off. Here's our fixture. You can see that. That's already ready to go. So we turn our beauty ring back on and we'll go ahead and simulate this. All right, blue indicating the stock that we're going to be removing. Green is a finished face. And we'll go ahead and start this. And we're going to be using a 1/2 inch 3-flute end mill to machine this. Now, when we first start, that's going to be the deepest cut that it's taken. But I have this set at a 200,000th step over. So every time it makes a pass around, it's going to move in another 200,000ths and then come up as it needs to and end up making sort of a stair step look on this angular face. Let's go ahead and speed it up so we can get through that kind of quickly. You can see what it's doing. And it's just going to be a one pass all the way up to the top, just like you see right there. I'm going to go ahead and show you what this looks like on the edge. So that's the face that we're going to have right here once this is finished and we go over to the lathe to machine it, to finish it. My goal was to go to the lathe and have minimal stock, you know, maybe taking 2 passes across there to clean it up. You know, one to kind of get the stair step down about even, and if we need to, one more pass just to kind of make a clean cut across there. All right, so we'll go back to our home view and I'll slow this down and we'll re-simulate this. So the next phase is going to be facing the top of it right there. I'm going to be coming in there with my 1-inch tongue alloy tongue force wreck and just making one cut across that face just to clean that up. And then once we clean that up, then we'll grab a chamfer tool and just chamfer that inside corner. I'm not going to worry about chamfering the outside corner at this point because I can do that in a lathe once I run my tool across there to clean it up. So that's an example of our program that we're going to be running in our CNC mill. So we'll go on out there and see if we can make this happen. I just made my air cut test on this right there and everything seems like it's just like it's supposed to be. I don't see any errors or anything I'm having to tweak, so everything's looking good. I'm going to go ahead and machine this one, do it off camera so that I can focus on the job at hand, make sure everything is correct and I don't have any kind of screw ups. And once I know that we have a proven program and we're making good parts, I'll bring you guys back. We'll set the camera up and get a little bit of the milling action on this guy right here. I think we got some great results out of our first test cut there. Everything looks to be exactly how we designed it to be. All of our stair step rough end cuts look good, exactly where it needs to be. The finish from the 1-inch insert mill looks pretty good. And again, like I said, when I go to the lathe, I can certainly take just like a 5-thou pass across that just to clean it up and make it look consistent with the rest of it whenever we face that off. I'm contemplating in my head to just go ahead and get all these rough, so we'll have 7 more to do, and then maybe test it with a ball mill on the first one and just let it rip. It's going to take like 2 hours to mill it, but we may try it just to kind of see what kind of finish that we can get out of it, and I can work on some other things while that is cutting. And if I don't like the finish, we can always go to the lathe and skin that off of there, make a pass to clean it up. Keep in mind, as I had said before, these are simply what they call beauty rings or trim rings. So mechanically, they're not doing anything. There's nothing matching up. We're just trying to match the sample as close as we can because a light is going to be bolted into this, and this is the base of it, what you're looking at. Whenever you walk by these lights, that's what you see when you go by. So if this face is 5 thousandths lower than another one, if this face is 5 thousandths lower, you know, things like that, it's not a big deal because it's not a functional piece. It's a decorative trim piece is what we're doing. So let's go ahead and we'll get the second one loaded up. We'll get the camera on board and see if we can show you guys what the chips look like. That 1/2-inch 3-flute mill worked pretty good. I could tell that it sounded like it was a little bit of harmonics going on with it, you know, because of the depth that we were cutting, but it seemed consistent all the way up here to the top. I thought it was going to, you know, slowly start backing off on that sort of harmonic chattery sound, but it stayed pretty consistent. So I think that's just, it is what it is, but it did a really good job. And you can see the chips right here. By the way, we are running a 6 thousandths per tooth chip load on that. I was trying to decrease the amount of time that we're milling on it the most I can, but that is pretty good right there. I'm afraid to give it any more load than what it already is, so we're just gonna run it like we have it. All right, let's let her rip. As usual, after the milling, I'll stop and clear the lens off in case it's covered up, but I try to do the best I can to give you the best shot that I can there. So let's let her rip. So this is a spiral pattern that we're going to be using here. It's just going to have a constant engagement all the way around, but an equal engagement all the way around the entire part. Sorry about the coolant. Nothing I can do about it at this point. So here we've got just about full engagement on the cutter, and it's doing really well. So this is running at 6,000 RPM with a 6,000 per tooth chip load. It sounds like we're getting a slight amount of harmonics and chatter on it, but I think it's just about as normal as I can get it, the best that I can get it there. So we're just gonna let it run. This cut will take approximately 10 minutes to complete. All right, the roughing is finished there, and I apologize about the coolant on the lens. Nothing I can do about it, but we'll get her cleaned off and get this part finished. This is our 1-inch tongue force rec. We're just gonna skim that top face. It's not gonna take much, 10-15 thou. Just cleaning it up. This is our last cutter of the operation here. This is a 3/8 mill drill that we use for chamfering, and it's just really going to touch that chamfer, just barely clean it up. Well, there we have it, end of program. We're going to move down out of the way, and that'll finish this up. So when it stops, we have a total cycle time of 13 minutes and 23 seconds. So there's the one you guys just saw being cut. Looks pretty good, doesn't it? I think it does anyway. We'll go ahead and get this swapped out, and we're just gonna keep it moving. We've got 6 more to rough. This can get a little tricky getting out of here. That coolant just really makes everything stick, but having our compressed air seems to help. Picks it up just enough we can get it out of there. And then the same thing with this piece. Let's see if I can get it. See, it's really stuck on there. Coming through the side with a little bit of air. It helps lift it and break that bond. So there we go. Looks pretty good. I like it. Let's keep it going. So we got 3 done. We're on number 4. Got those 4 left to rough in. Everything is going great. Love seeing the rooster tails. I just haven't got to experience that a whole lot in my career. Fun seeing it happen over here on the flex. All right, guys, we're just gonna keep it going. I'm gonna keep these things getting roughed out and try to knock them out as soon as I can. The chip pan was getting absolutely full, so I had to get it cleaned out. Make a little bit more room for the rest of the aluminum coming through here. Well, the flex just finished roughing in number 8. So all of our roughing tool paths are now complete, and they have been consistent at right at 14 minutes each one to get completed. So what I have decided to do at this point, I would like to go ahead and sacrifice a little bit of time and use a ball nose end mill and see what kind of finish I can get on this guy. The reason why I was kind of leaning away from that is because it's probably going to take about 2 hours to get that completed. It's a lot of little tiny step overs to get that completed right there. So if I end up going that route, honestly, I would be kind of losing time on what I quoted to machine these guys. But the trade-off is that I have other jobs that I can be working on. I have content, I got videos that I can be editing. I got a lot of content I got to edit. So I can continue to stay busy and be productive doing other things while the flex is over here working on these guys, putting a nice finish on it. But we're only going to do one just to see. We're going to test the waters with one. This one right here. I got to work on the program, and when I do, we'll come out here and we'll start on that one. We'll let it run, and if I'm not happy with the finish that it puts on that, then we'll go ahead and change our plan and go to the pacemaker and use the lathe to make that cut across there. But I would really love to use my flex to try to get this job done. So it's really going to determine how long it really takes to do that and the finish that it's going to put on there. All right, so once I'm ready to get to that point, I'll bring you guys back and we'll start on that. I'm going to go in there to the desk now and start working on the tool path for the finishing op here. Okay, we'll keep you guys updated on how we progress. My cutters arrived that I ordered whenever I was gearing up to start this aluminum job here, and unfortunately it just took a little while to get here. the courier held on to them and they just delivered them late. So they just got here. So I've got a flat bottom end mill and a ball nose end mill, which is what I was planning on using for this job. So I had to just move forward, and I had a different end mill already that we used, but this was the one that we were going to use for that inside bore, for that finishing pass. That's a beautiful looking end mill right there. 3-flute polished carbide. It's got a 1-inch length to cut, and we'll have it in the toolbox to try on the next job whenever we're working on some aluminum. It's a pretty looking cutter. But so here's the one that we're going to go ahead and get installed and give this a try today. So this is going to be our ball mill right here. 3-flute ball mill, polished, uncoated for aluminum. I actually talked to somebody over there at Helical so that they could recommend the best cutter for this application, and these two guys right here are what they recommended for what I was doing, matching the length of cut to keep the, you can see this one is actually kind of short. It's got a 3/4 inch length of cut there, flute length, and they suggested trying to keep it as short as possible to maximize the rigidity and finish on the machine there. So this is the one that they recommended. So we're going to get this guy loaded up in one of our Heimer shrink fit holders, and I'm really hoping that this right here is going to help us get a nice finish when we're setting up to do our 3D finishing on the aluminum disc. So we'll go ahead and get one of these guys installed now. I'm about 15 minutes into our finishing program here, and I had Aaron at Flex. I got on the phone with him, and he was able to help walk me through how to be able to stop this program stop it mid-program, and be able to open the door and look in there really close and inspect the finish, and then be able to successfully start the program back up and keep it going. My plan was to just cut it for about 15 minutes, stop it, look at it, and see if I can make a determination at that point if the finish looked good enough to continue. And I think the finish looked great. I'll throw a couple photos up there on the screen. That's exactly what I saw. Now keep in mind, anytime you show photos of finishes, those photos always make things look a little bit blown out. It really seems to enhance features of the finish that doesn't really represent how it looks with your naked eye. So it might look a little bit rough there in the picture because that's how those finishes always look. But I thought it looked really good. It had a nice, pretty, glossy look to it. So I decided to go ahead. We're gonna finish this one. I wanna get through this first one and then get a good look at it, the overall entire face, and see what it looks like. I feel confident that we're gonna have a good part there. If I need to change anything, it would actually be the step over. I have it set at 25,000 step over, which is kind of coarse, but that set me at about 2-hour cycle time. If I change it from 25 down to 20,000 step over, it added almost a half hour to that. So I was trying to keep it right around the 2-hour mark on cutting it. So we'll finish this guy, this number one here, and take a better look at it and kind of make a determination on whether we're going to move forward with all 8 of them at this point, and then we'll go from there. So it's going to be a long cycle here, but I got other things in the shop here that's going to keep me busy. One of the beautiful things about having a CNC machine, you can walk away from it and it's like a robot. It's just going to make your part while you're busy doing other things. So it's not a total loss of time, because I'm still going to be busy doing other things. I got her chip pan pretty well cleaned out. I need to finish it, but so this is 4 trash cans now that I filled up. I did have some steel chips in there, so half the can was steel chips, but we've been making quite a few aluminum chips on this project right here. So this is just going to go in. Joe's got a aluminum roll off over there at the welding shop, and I'm just going to dump this stuff over there into his roll off. So anyway, we'll give you guys an update when this is finished, and we'll get a good look at how our aluminum discs are finishing. And I got to say, the helical end mill seems to be doing a really good job. I think they led me right on to the proper tool that I need for this job here. All right, guys. Well, there is disc number 1 finished up in the flex using our ball mill there. And I got to say, I'm happy with the results of the ball mill. I think it turned out really good. Now, the only issue I have with this first one is that there is a visual mark there where we actually stopped it to inspect it and then started again. I can actually see like a line around that one tool path there that it's kind of bothering me. It's probably fine, but it's more of a personal thing. And the problem is that this is what I was running into. If I have to start this over, I'm losing 2 hours. So I think what I want to do, I'm happy with the way this looks. I think this is gonna be fine just the way it is. All right, so I'm gonna go ahead and swap this out and start on another one and let it run. And I'm gonna leave for lunch. I'm usually gone for, I don't know, 45 minutes to an hour. And I'm gonna let the machine just run on the second one. This will be my first time turning a machine on, the CNC, and walking away from the shop and letting it run. I'm a little nervous about it, but I'm sure everything's gonna be just fine, because for the last 2 hours, there's been nothing wrong with this at all. I watched our chamfer tool. The chamfer did just fine. We did a 10,000ths chamfer break on that corner there. And I think everything is good. So what I'll do is I'll get through the other 8 over the next, today and tomorrow. And I'll probably set this one back up and make another cut on it after all of them are done, just to clean up that line right there. I hate that it did that, but that was the only way that I could be assured that we weren't gonna waste 2 hours cutting it. So I'll go ahead and swap it out. And just because of the amount of time it takes to cut this thing, I'm not gonna put camera on board. I'll just get a little video of the outside. You guys can kind of see the action. Once you see a minute of that, you'll know what it's gonna look like. All right. I'll let you guys know how the second one comes out with our, I guess that some people would consider lights out machining, which is something that I do every time I leave for lunch. I always turn all my LED lights off just to kind of save a few bucks on the power bill anyway. We'll see how that goes. Hopefully we won't have any kind of crashes while I'm gone. All right, disc number 2 just finished up. Got it cleaned off there, and I am liking it. I'm happy with it. I think that's a good looking finish. In fact, I had my customer come over here and look at these. So I've been building these for the welding and fab shop. And so I had him come over here and take a look at them and see what he thinks. And he absolutely loved the finish that it was putting on there. He goes, man, I don't see anything wrong with it. Why don't we just roll with this? So our plan is right now, we're just gonna go ahead and this is number 2. We're gonna finish all 8 of them right here on the flex using our ball mill to get this finished out. And I think it's gonna work really good. I think that his customer is gonna like them too. That's what he thinks. All I can think of is like worst case scenario, somebody, the end user, for some reason doesn't like this finish that's on there, a milled finish versus the lathe finish on the sample, is that we can easily set this back up in the lathe, adjust our compound to this angle right here, which I have it set to 12 degrees, and we can make one skim cut across that in the lathe to clean that up if we need to. But he says that they're good to go. I'm good with that. I'm just going to keep putting them in here and letting the machine do its thing. And by the way, I did go take my lunch break. I turned the lights out and everything was just fine. I was able to access my security cameras while I was gone and actually saw that the machine was still running. There was no crashes. It wasn't on fire. The building wasn't blown up. Everything worked really good. So that was my first time doing a lights out, walking away, leaving the building and letting it do its thing. And it worked really good. By the way, so we've got a total cycle time of 2 hours and 15 minutes to get this job completely done, or one piece for our finished cuts there. All right, so I'm happy with it. I'm gonna keep swapping these out and keeping the machine busy all day. Disc number 7 just finished, and we have one more to go. This guy right here. So I'm gonna go ahead and swap this out, put in number 8, and we are just about finished with all this right here. So I think for this last one, I haven't really been getting any kind of footage because it's just hard to show this operation there. But I think for this last one, I'm going to go ahead and put the camera in there. We're just going to do a time-lapse video, so it'll go pretty quick, and maybe you guys can get an idea of what it looks like doing that spiral pattern in there for the finished pass. But really excited to see this. The finish on all of them are turning out, to me, identical. They all look the same. They all have the same kind of finish. And I'm happy with the results. So I'm excited to see this number 8 get completed and get this job wrapped up. We have just about nearly reached the end of the line of this project. I'm really happy to see this number 8 disc is now milled and complete. And it looks good, just as consistent as the other 7 discs. We'll go ahead and get the clamp ring off and get it out of here. Just got to do a little bit of cleanup on all of them. I'll give them all wiped down, make them look presentable, and then I need to wrap them up, package them so that they don't get scratched for when the customers pick them up. That's really the last phase here. Besides, I got to get the machine, got to get it washed down. I tell you what, even though it's aluminum, these little fine shavings right here, all those little fine shavings, they are needle sharp because I've already had a few of them stuck in my finger. That's why I normally like wearing those orange or those black gloves, just to eliminate that kind of stuff. But I guess today I just didn't feel like putting any on. I don't know. Do that to get that ring off. It's really been helping. I am very happy to see this right here. This is awesome. I feel really, really good about how this project how it's turned out, the finish that we're getting, and the way they look. Honestly, I really like the way they look. They look good. Hopefully they're gonna be looking good to the customer too, and they're gonna like the way that they turned out. Guys, this job is done. It is 100% complete, minus getting them wrapped up, which I need to do for the delivery. I'm going to do that as soon as I'm done filming this little outro video right here. But guys, I am pleased with the outcome of these beauty rings. I was a little nervous going into it because this is a type of part that is supposed to look good. You know, it's a presentation. It's a trim piece for light fixtures, as I mentioned early in the video series there. There's going to be lights that get bolted to these, and these are more of like a base, how I understand it. And it's just a beauty ring to kind of fill a hole, fill a void in the ground, and I guess to make make the bottom of the light look nice and modern and functional. So I just think they turned out really good, and the Flex did a good job putting our finish on the outside. That was one of my biggest concerns and worries there, was just how that finish was going to look, you know, with it being milled. This was certainly a job that I could have went into using all manual machines, using my American pacemaker to get this counterbore done, and you know, everything. We could have went to the mill to drill the holes, but I really took this job as a good opportunity to continue my education in CAD and CAM and lean on my CNC machines to get jobs like this done. And I really think it worked out well. You know, these finishing cuts, as I had mentioned, they took a long time to do, but I was able to keep myself busy with other things while the machine was over there cutting, and I wasn't having to stand there and hand crank the handle every single pass on 8 of these right there. That is one of the main reasons why I did want to use a CNC. I've had some guys asking, like, this is really a lathe job. The sample there, that somebody made that on a lathe. If I would have had a large enough swing to do it in the CNC, I would have loved to have done that. But I wanted to save myself a lot of that hand cranking across this angle here and just go with the Flex to do that job. But I'm happy with the outcome. They look really nice. And I hope that the end user, the end customer, feels the same way about this and that they like them just as much. So it's been a great project. I want to give a big thanks to Kevin over mechanicaladvantage.com for answering my emails, my cries for help. You know, Kevin always jumps in there and helps me with these programs to ensure that I'm doing things right. And I always have mistakes in there that he finds as we're going through there. And he teaches me. He says, no, this is what you need to do. And we go in there, we make our adjustments. And I come out here to the machine, I make my air cuts on it to kind of prove that the tool's in the right location, and everything worked out good. I didn't have any problems with this job whatsoever. So it's all good. So I'm gonna go ahead and wrap this up and get these guys wrapped up. I got some packing that I need to get them wrapped up and protect them, and go ahead and get them delivered, get them dropped off, and this will be the conclusion of this project for me. So I hope you guys enjoyed the series, enjoyed following along. I enjoyed sharing everything that I did with you on the machine work of this project, and I just hope my audience really enjoyed it too. So I hope to see you back here for the next project.